IBM. He was the main person who did that. And apart from that, CDAC. So Dr. Anindita Banerjee, the project manager, she was part of the one to make that. So we're just waiting for some more participants to join and the panelists also to join. So I welcome all of the participants who have joined. Some of them are still joining. This is exam time. I know that most of you may be in examination duties and other programs. So while you are all busy, so we will not take much delay. We'll go into it. So let me introduce you to the syllabus once. We'll look at that. It's a combination of QT-03 and QT-04. Share karo. Ramesh, share the. Yeah, I welcome Professor Vineet Sahula, Chief Investigator of Electronics and ICT Academy. Introducing Radhakrishna, who is sitting next to me. He's helping you in the WhatsApp group and helping in that. And we have joint coordinator here with us, Dr. Vikash Kumar, and he is Assistant Professor in Computer Science and Engineering Department, MNIT Jaipur. He will be the joint principal coordinator from MNIT. There will be there's Dr. Shivansh Mishra, who is there from IIITM Jabalpur. He'll be the joint principal coordinator from that academy. NIT Patna will have Dr. Rajiv Arya, who will be joining, and from MNIT it will be Dr. Vikash Kumar. Vikash Kumar is already there on the WhatsApp group, and also he'll be helping you. So there are more participants. So is my audio not clear?
I think it is clear. It's coming to me. Some participant might have a problem.
So
Clear, sir,
please,
clear.
it is coming clear. So participants, please check audio at your side. There may be some issues, right? Because on the YouTube also it is working fine. We're checking that, so that should be fine. So let me start by welcoming all of you for this program, especially Professor Vineet Sahula, who is our Chief Investigator. The main speakers have joined, Dr. Jaykumar Raitishankar and Mr. Anand Raman, and also we have Dr. Ashwath Babu joining with us. And thank you so much for all of you joining here. And here on the screen, we have the schedule of the programming, schedule of the program, QT-03, the third course. And we have here basic quantum programming, which will be taught here in this course, which is part of the third course in the quantum minor degree for AICT affiliated colleges. So we have some topics from QT-04, which are also part of the course called Quantum Technologies Lab. So you can look at that, and then this program will run till June 6th. Initially, we looked at June 7th. June 7th is a public holiday. Because it's a public holiday, we are not in a position to have a class on that day. So the class has been preponed. So we have 3 lectures on May 24th and 3 lectures on May 31st. So with these dates, we will see that the program will continue like that. So that's how it will be. So as you start from May 16th onwards, that is today, we'll have the introduction for some time. After that, we'll look at Dr. Jaykumar taking over the basics of programming, and with a introduction or revision of data structures you can look at, and also trying to see how it can be done, right? And then we have object-oriented programming. Then we have simple benchmarking, runtime algorithms, scientific plotting, sorting and searching algorithms, numerical integration and differential equations. So that is where we have Dr. Ashwath Babu coming in. So he will be teaching us differential equations and linear order, second order equations, differential equations. Boundary value problems will be discussed by Dr. Ashwath Babu. So he'll be leading us the sessions on May 21st and 22nd. The first quiz will be after the May 22nd class. We'll have the first quiz open. Of course, as you know, most of you would have attended the earlier 2 courses. The quiz will be open for around 32 hours, starting from 4 o'clock, going up till next day midnight. So that's about 32 hours you'll have to take the exam. After that, we'll again have Dr. Mustafizur Rahman joining with us from IBM, taking the sessions on numerical techniques in linear algebra, matrix inverse, eigenvalues, diagonalization, single value decomposition, and all that, right? So that's again we have. Then we go back to quantum simulators again, where we'll get an introduction to various simulators that are there. You can also refer. Meanwhile, we'll share you QT-02, few links where quantum simulators were introduced briefly. So that's where we'll like to look at. And then we have Satyaprakash Palaniappan, who will be dealing with more details in that. Then we have implementing algorithms on cloud-based quantum computers by Ms. Janani. Janani ma'am is an IBM educator, and she's well versed, and she has taken lectures in recent workshops in IIT Kanpur. So we have running algorithms on cloud-based quantum processor also. So they will be handled. And after that, you'll have quiz 2. So of course, as of now, we'll have one more IBM expert coming in. Dr. Ritajit will be joining. So maybe he'll be taking this slot 1 hour. We thought you can have a slight relaxation, but IBM, one of the expert is available. So we'll have a class. Please correct the date. That will be 29th itself. So from this thing, so it is not from 4 to 5. So that extra lecture will come there. And then we'll move forward with Mustafizur Rahman coming back in the next weekend. So 2 weekends he'll be there with us. So he'll be discussing numerical techniques in probability and statistics, error analysis, hypothesis testing, and all that. Then June 2nd onwards, we have Mr. Anand Raman, who is with us today. He will talk about integration of HPC with quantum computers. So he'll combine CUDA-Q and NVIDIA. So the NVIDIA processors and the quantum processors will how to make them work together. So that's one thing. For first time, we have a speaker from Australia, Dr. Mick Conroy. His confirmation is awaited, but he's from an organization called QCTRL, or Q Control, you can think of. And he'll be talking about integration of a tool called FireOpal with Qiskit. And then, of course, he'll share some thoughts. And there you have a quiz. I think this is the quiz I'm talking about. Sorry, June 3rd is where again one more expert from IBM will be coming, and he'll be sharing on June 3rd. June 4th, we have Dr. Santosh Viparthi speaking on computer vision using quantum machine learning. Of course, he'll show us some implementations on Penny Lane. That's one. And Dr. Anindita Banerjee will be talking about optics, which is QT-04 course. So interferometry, diffraction, microscopy, polarization, these are some theoretical concepts, but she said that she will discuss what's happening on these aspects of implementation aspects here. And then she will obviously take you through a study on QSIM, which of course, I think Dr. Jaykumar will introduce. So she will discuss some of the things. And also in CDAC, they've built a simple sample. They will teach us how to build a 1-qubit computer, 1-qubit quantum computer. Very how they have done it and what they have done in CDAC is what they'll share. So that's industry perspective and challenges. And half an hour after that, June 6th, we'll conclude with the valedictory session. We are hoping to complete the quizzes. This time we'll not have 4 quizzes, but only 3 quizzes, because that generation of the result and the certification is taking a lot of time. So we'll conclude with 3 quizzes. So some of those topics which are covered later, we'll give you an assignment or something, but which will not be evaluated. So after quiz 3, we will calculate your grade, and hopefully on the last day, on June 6th, we want to complete that whole process of releasing the certificates also. Hopefully, we'll do that, but maybe definitely by June 10th, we will conclude with all the certificates being issued. So Dr. Vikash is here with us, so he will help us to conclude these aspects. So this is the basic introduction for us for the schedule. And so now I will request some of our experts who are with us to share a broad thought on these. Some of our chief investigator and our joint principal coordinators are there who are joined as panelists. They will share their thoughts. Firstly, I will request our chief investigator, Professor Vineet Sahula, professor in electronics and communication engineering in MNIT Jaipur. Sir has been the chief investigator of the Electronics and ICT Academy in MNIT Jaipur from 2016. And he's also the the committee convener for all the ICT academies. So if you have, we have 7 academies, and sir is the convener of that coordinators academy, CI's academy committee, you can think of, right? So that's where he is. And then sir also personally works on quantum. So that's another special privilege we have. You would have heard him on World Quantum Day and other aspects also, where sir spoke and introduced us with that. So at this time, I will invite Professor Vineet Sahula to share a few thoughts. on this course and
Yeah.
also encourage the participants with few words of advice. Saul, sir.
Thank you, Dr. Pili. I think there is enough motivation in the environment, and I'm just becoming part of that motivation and not giving motivation that way. We have good speakers and very enthusiastic participants here. First of all, let me thank all the speakers for having kindly agreed and spared their valuable time and really taking ahead the noble cause here to spread the quantum across the country to the nook and corners. Dr. Ashwath Babu, Dr. Jay Kumar, thank you, and other 4 or 5 speakers, Mr. Mustafa Rozur, Ms. Janani, Mr. Anand Kumar, Dr. Mick Conway, our own faculty alumni, Dr. Santosh Parthi, IIT Roperd, and Ms. Ananta Banerjee. We also would like to thank Professor N.P. Padi Sahab because he has actually motivated us and facilitated us to offer you a series of these programs which would lead to a PG certification at the end, which I think Dr. Pilli and Dr. Vikas would be very happy to award you if you attend all the 4 or 5, 6 courses. I think that is in pipeline. I just want to indicate to you what other courses are there which actually match with the AICTE proposition. So actually AICTE, All India Council of Technical Education, has proposed that a BTech course might have different minors in specialized areas, and this could be implemented by any institute in all over India. In that mission of motivating institutes, Professor Sitaraman Sahab, who is chairman of AICTE, he has sent a letter and where he just indicates that a teacher which is teaching core courses can also be taking up all emerging areas, one of the minors in that area, if he has completed 10 credit courses online on MOOCs, maybe through SWAYAM, NPTEL, or any other Government of India portal. The EICT academies are funded by Ministry of Electronics. In that sense, we are fully funded by government, and our all programs qualify under the GOE portal delivery and that part of it. So coming to the quantum, the list is here. I hope my slides are visible. I'm presuming that.
Yes, sir. Slides are visible. Sir.
So like AICT has proposed that we can have about 5 of those, where 1 is this, 2 is this, 3 is QT0, QT4, one of them, and one of the 5 to 8, and one of the 9 to 11. So in those all domains, we are offering the 5 FDPs, where we are already into QT-03 and QT-04 inclusion and offering this FDP, which is current FDP. You may please look forward to our other offerings in the coming months, which Dr. Pilli will also apprise you for. And I think I will not take much time here. And again, thank Professor N.P. Padi Sahab, our speakers, and now it's my duty to thank our coordinators and co-CI, Dr. Pilli, who has really taken a good initiative and worked hard a lot about offering these series of courses. Thanks to Dr. Vikas and other team members which are here at AICT Academy, Dr. Ramesh, Dr. Geeta, and some of the PhD students of Dr. Pili. So thank you, you all. I welcome all the participants and wish them a happy learning for this course and the future courses. Thank you very much.
Thank you, Saul, sir. At this time, I would also like to say a few words related to these courses. So we are trying to look at, initially we were trying to look at 6 courses being offered. But now, as Saul sir has just mentioned, 5 courses will be sufficient from the whole list of courses that are being offered. So we can try to look at these combinations. and try to do these courses. And for those who have missed QT-01, QT-02, we are trying to convert these courses into MOOC courses, which will be available online with the quizzes also available. The same certificate will be issued from all the academies that are there. So the certificate that for those who have done the course and those who do it on the MOOC, which we may offer through NPTEL or something, any other mode that we offer, or our academy itself may offer this panel. So then you can try to look at those videos, and you can try to look at how to go about, and you can understand, complete those courses, get the certificate, right? So that's another option. But QT-01, 02 are not the only essential things. If you look at, if you do any 5 courses, we will try to issue the certificate for PG diploma. That's what we are trying to make it available. But of course, IBM also is looking forward to a kind of face-to-face interaction with these participants. Most of the participants have some of them have completed QT-01 and 02, but at least those who cover most of these courses, they will be wanting to have a face-to-face interaction for a weekend at 5 or 6 places. And once these 5 or 6 places meeting happens, we will be able to have this, what do you say, the interaction, which will help us to take it forward. And maybe we'll also have an exam on these aspects when we have a physical interaction. So already you're doing the quizzes, but we will also try to look at how to take it forward, right? So that's what our suggestion will be, to take it forward. So don't worry, there are some queries which are coming on, and you can try to do that. The whole idea is that we'll have most of these courses completed, at least 5 of them. So earlier the requirement was 18 credits. Now the requirement is for 15 credits. So you can try to look at that, right? So yeah, there are some queries which are coming for those who are not able to attend in person, right? So we will try to look at doing what is called a proctored environment we have to create. So we will see how that will be available in other countries, or how you can do a proctored course. So we'll try to do that, right? So I can understand, yeah, Masood, we know that you are there from Bangladesh. So many of them are from other countries, they are able to attend. So as I've already mentioned, Q1 and Q2, they will be repeated in the next year, 2025, in a FDP mode, right? But for those who want to do it now itself, in a month or 2 months time, we will offer them as a MOOC course, and then you can take it along with these parallel courses which are running. You can complete QT-01 and QT-02. That's what we can try to help. All those who are registered for QT-03, we will make the videos available. Okay, that's what we'll try to look at. Yeah, the postgraduate diploma, as we usually see, which is offered anywhere, has a face-to-face interaction. There will be an offline interaction which is required for a period. Usually it is for more number of days, but we want to do it in less number of days on a weekend, and do it at multiple places in our country. Because there are 7 academies, and more other partners are also there with us. But soon I will be sharing a form with you about the dates and times that are convenient for you. So we will try to schedule those. Maybe 100 people in each center, like that we'll try to do, and we'll try to run about 10 centers. We'll try to do that, and definitely we'll try to cover main cities, because people can come there on a weekend, complete their course, take the exam, and go back, right? So so there are 5 QTs which are to be covered, as I see in the queries that are coming, right? So 5 QTs, earlier it was 6, that is 15 credits you can look at. Now we can try to complete that part is there. So this is basically quantum awareness, right? The schedule for this will be also put up. It's not there in that system which is displaying. Any of the 6, in fact, any of the 5, because quantum has 12 courses for minor degree, but there is a blockchain course which is having less number of courses. There are degrees, minor degrees, which are offered in artificial intelligence, which also have less number of courses. So we are now looking at 5 courses to be completed. That is 15 credits to be completed. Hopefully, once we complete 15 credits, some of you have completed 6 credits already. Some of you are completing this. Going to be the next 3 credits will be coming from this course, though it's a programming course. Theory and online both will be done at the same time. So most of you have listened to Dr. Jaykumar in the previous course. We will make the videos available for you for looking back. At least Dr. Jaykumar has discussed some of the aspects in the previous time. So it's good that if you take it forward, read it, prepare and come, it will be advantage for you. So that's the thing that is there. We are not assuring anything about placements or better career opportunities, or whether it's going to be used in any other government organization. We don't know. But what I tend to look at is many of you, when these MTech programs in quantum computing or BTech program in quantum computing engineering or quantum technologies will start, I think if you have this qualification or if this degree, you can take it forward, right? A formal degree is different. The minor degree is being offered in AICTE affiliated affiliated engineering colleges as a minor degree. Somebody is doing BTech electronics, somebody is doing BTech computer science, somebody is doing BTech civil. They can take a minor in quantum. So that is what this course is about, which is being offered. Now, what we are trying to do here in this EICT Academy is offer training for faculty who will teach. So if your college is going to take this as a future course someday later, offer quantum, you are equipped to teach those courses straight away. And you can do that, right? Those who have not done QT-01 and QT-02, as I've been already mentioning, you can take it through this online mode. You can learn the course, because the certificate may not be there with you, but if you have the knowledge, I think that should be fine. And we will make these courses available online with the certification, with quizzes, and the same certificate will be issued at that time once you complete the course. Similar looking certificate will be issued. So those will be counted against the credits. So please don't worry about that, right? If you do an online course through MOOC, or you do an online FDP, both will be at the same level, and we will count those, because we are the people who are going to conduct both of them, right? So please give us some time. Actually, one after the other we are having. QT-01, QT-02 videos are available on YouTube. We will make them available to you. You can go through those videos and you can do that, right? So, okay, more questions. QT-01, 02 will start in 2026 again. The schedule for when after Dr. Jaykumar gives a break, or towards the end of the course, today's class, I will share with you the schedule of 5, 6, 7, and 8. 5, 6, 7, and 8, and we can do that, right? So please, I look forward for your time. Yeah, we are doing that national credit framework. We are trying to do that, but it'll take some time. Their requirements are very rigid, and also little strict, because most of you are not able to come face-to-face interaction meetings. So the national credit framework has a physical interaction requirement. So we are trying to work out the best way possible. There is another option called proctored, but I don't know how to do it for other countries. Let's see how best we can work out. If there is any prometric testing center, maybe you'll have to pay a little bit extra. We'll send them the question paper, they'll conduct the thing. So these are all things which are working out. But these handling these 1,000 participants and certifying them is taking a lot of time. You can understand us, so you can please wait. Give us time, because myself or Vikas or Mahipal, who was helping, we all have our full teaching load and research, and our research students, MTech students and all. So with all these, we are doing that. So kindly bear with us for some time, right? So let me invite this time for, one of the Canvas. Why Canvas is important, why WebEx is important, 2 questions. WebEx, we are here and you are open to join. So that's the thing. The webinar will be conducted on WebEx, but the material and the video recordings will be shared via Canvas, and the quizzes will be conducted on Canvas. So the quiz modality is something like this, that we usually announce the course at quiz at 4 o'clock after the class is over. You don't have to take it immediately. You can take it in the next 32 hours. time. The next whole day is available. And sometimes if you are not able to complete, we extend the time also for some time till you are able to take all the quizzes. So we definitely encourage you to do it forward. So no problem. Don't worry about that. But attendance also, yes, I understand that some of you will be in the office, or some of you may have a meeting at that time. You may not be able to attend. So please listen to the recording at the end. So please try to maintain about 75% of the classes, which is usually for any course. Everybody may not be able to make 100% classes. So please try to do it for 75% at least. And you have to get a 40% weightage in the quiz. And that's what is another thing that you can look at, right? So hopefully I've answered most of the questions, and I'll go through the quiz. I'll go through these things, how you look at. Yeah, presently the credits that we are offering is through a certificate. So that weightage will be 3 credits. But mapping with APAR will take some time and give us some time. We are still working on that. Yeah, let's hope we'll move forward. We'll listen to Dr. Jaykumar before he starts. He starts his lecture at 3 o'clock, but I want him to give the thing. And I would like to welcome Dr. Jaykumar and speak to him, because I want him to speak, because he's the one who has kind of put all the topics together and put the team together here. Many of them are his colleagues and friends, whom he has, I mean, they have been working together and they've been doing so many workshops. If you visit Dr. Jaykumar's LinkedIn profile, you will see where all he has been speaking, from IISc, all the IITs, all the NITs, and many engineering colleges. And he's also running a startup called Anutantra. Dr. Jaykumar, if you're available, you can turn on your camera and then you can start taking. Just give a brief overview about how you would like to go about this course, and then we can take it forward. Dr. Jaykumar, yeah.
Good afternoon, sir. Good afternoon. Am I audible?
Yes, sir.
Okay, thank you. Thank you. So, QT-03 is a little basic thing when you compare to QT-01 and QT-02, more and more about computer science perspective. Okay, so this might be easy for computer science and circuit branches people, little difficult for non-circuit branches people who never went into programming. Okay, so basically I will describe what this course contains about. It contains about the basics of programming. So how we teach for bachelor students from starting from the scratch. So it will introduce basics of programming, what are the data types and data structure, and how you can store all your information in a structured way, and about the complexity. Okay, so all this stuff is highly relevant to programming aspects. Okay, so the same way we can do for quantum computing also, because quantum computing, if you want to do any operation, we need to go through programming. Okay, so little difference are there between the classical programming and quantum programming. So that is why this subject is a overlap between classical and also quantum. So it involves about description about classical algorithms. It displays about sorting algorithm, searching algorithm, arithmetic operations and arithmetic algorithms, and numerical differential equations. So what are the scientific computation we are about to do? We can discuss in this subject, as well as a little brief introduction about linear algebra and probability statistics. Experts from IBM Quantum, they will discuss with you with use case. Okay, so this is very good in these aspects, and it slowly linear towards to quantum algorithms. How will you write a quantum program? How will you run on actual quantum processor? Everything will be discussed. And a few more topics are covered, like quantum simulators. So we will introduce a variety of quantum simulator where you can have hands-on, where you can run all your topics which is covered in QT-01 and QT-02. So this is about the overall structure about this course. Shall we start, sir? Hello.
Sir, we'll start your lecture at 3. So
Okay.
we'll give the options to Dr. Ashwath and others also to share.
Fine, sir. Fine.
At 3 o'clock
Okay.
we'll start. Yeah. Thank you so much. Dr. Ashwath, if you're available.
Yes, sir. Can you hear me?
Yes, yes, yes. Please go ahead.
Okay. Very good afternoon to all of you, all the participants. And first and foremost, I would like to thank the organizers led by Professor Pillai to invite all the panel members and giving us the opportunity to spread the whatever knowledge what we have with regards to quantum computing. So, yeah, having thanked them, and I would like to give a small motivation to all the participants. As you can see, the quantum computing is picking up, and it's a field everybody is looking after, whether it is a government sector or a private sector. It is being recognized by even the government is currently. So Indian government is now pouring more than a few 6,000 crores for quantum computing research. So, and as you can also see the current the placement scenario is we more concentrated on the service sector. All the industry, the IT industry is facing too much of layoffs these days. So it's time for us to get into the product sector. So now Indian government has supported establishing a quantum hardware in India, that is QT-03 is the first company in India and almost a fifth company in all over Asia to establish a quantum hardware in Asia. So things are picking up. So it's time for us all to look for it and get and get computing, whether it is a software or a hardware. Okay. So, and AICT has fortunately come up with this minor program, and at the same time, the institutes like MNIT came forward to conduct a full-fledged FTP on all the modules. So that is a commendable job MNIT is doing. So you being registered, showing your passion to get into the quantum computing is appreciated. So please give us some time and try to learn whatever you could, and also motivate your students to get into the field. Okay. So once you get develop your expertise in this field, you would be able to encourage your students and also train and guide your students. So that was the objective of AICT and also objective of our Ministry of Education in the field of quantum computing. So from our end, panelist end, we try our best to convince you people and learn and understand whatever quantum computing which we would be doing. So yeah, that's motivation from my end. The government is looking, and the current scenario is demanding for a quantum computing research and also quantum computing education, I would say. So yeah, please keep in the loop and attend all the sessions. Don't neglect any session. So by any chance, some other commitments you're not able to join, check the recording. That is one beautiful thing MNIT is extending. You can just cover the content even if you have missed. So please attend the quizzes also. Those are like very, very important. So just to assess how much you have gathered by attending the session. Okay. Please don't hesitate that you would not do well. It's a part of the learning. You can always pick up, right? So yeah, that's all from my end. If you have anything, you people always welcome to reach to all the panel members and check about if there is any issue with regards to learning. Okay, thank you, Pillai sir, once again. So over to you, sir.
Thank you, sir. Thank you so much, Ashwath sir. We have Dr. Shivansh Mishra also, who is Joint Principal Coordinator. I would request him to give greetings. Professor Aparajita Oja could not join us. She is the Chief Investigator from AICT Academy, IIITM Jabalpur. Dr. Shivansh Mishra will share a few thoughts with us. I'll also request Dr. Ananda Raman also next to share few thoughts, right? So Dr. Shivansh Mishra now.
Good afternoon, sir, and thank you for giving me this particular opportunity. I am very thankful to the EICT Academy, to all my colleagues who have helped to make this FDP success. And I hope this incentive of this initiative of research and talks about quantum will carry on. So this is particularly a very interesting and the latest branch of research that has come up, and applications are being found in different areas in order to optimize, in order to check out new avenues where the technology can be improved upon. So my particular area of research is social network analysis, and here also, rather than just being simple applications such as the quantum machine learning, even algorithms which apply the quantum concepts to human-based process such as information diffusion, community detection, and other things are being used. So I hope that all the participants will gain some knowledge from these sessions, which will help them in order to further their understanding as well as open new avenues for them to explore new opportunities. And I thank Professor Abhrajita Ahuja for being such an active member of the EICT team, and she is basically the whatever FDPs are handled from IIIT Jabalpur side. She takes a very active part, and she is the one who gives us the motivation to keep doing this. I also thank Professor Vineet Sahula for being here. Thank you.
Thank you so much. I request Dr. Anand Raman to share few thoughts.
Yeah, good afternoon, sir. Yeah.
Yes, sir. Yes, sir. Please go ahead.
Yeah. Thank you for welcoming me as resource person here. So I work as a HPC engineer in Nizer Bhubaneswar, scientific officer. So I'm looking after HPC for last 14 years. Worked in JNCSR Bangalore also. So now why we have to integrate HPC with the quantum computer? Because through HPC we are able to solve all the computational problems, computer simulations, scientific simulations. Okay, but it takes huge resources, too much CPU resource, too much GPU resource, and too much electricity. And even if you give all this also, the problem takes too much time to solve it. So now, earlier we are using HPC. Earlier we could not able to use normal computer for scientific simulations. We went to supercomputers. Then we built HPC with commodity clusters, because supercomputers are costly and we cannot build. So we went for commodity cluster. We can buy any servers from the market, and we can buy intermediate interconnect switches. We can connect everything as a cluster. Then we can compute our solution. So now even this is not possible for atomic scale simulations. So now the era is now quantum. So we have to go for quantum. Otherwise we cannot handle the power usage, everything. So power is the main concern, and the time to solution. So we need now quantum computing for solving some of the unsolvable systems in weather predictions, oil resource exploration, even animation, everything. So requires quantum computing. So highly parallel things. So now we are in the hybrid era of quantum and HPC. Maybe we don't know, maybe in after 10 or 15 years we will go to complete quantum for this kind of simulations, but now at least for next 20 years we will be in the hybrid mode. So we should know how to integrate classical and quantum to get more performance from it. So we will try to discuss those things on July 2. Yeah. Thank you, sir. Thank you for the opportunity. That's all from my end. Yeah.
Thank you. Thank you so much, sir. Thank you so much. So here Radhakrishna is there. One of the other student, Dr. Anand is there. Anand completed his PhD from MNIT Jaipur. So both of them will be there on the WhatsApp group to help you. We have participants coming from all the academies. As you listen to Dr. Shivansh Mishra from IIITDM Jabalpur, there is a good number of students who have joined. There's another group from NIT Patna EACT Academy. Dr. Ajiv Arya will be joining, so he is maintaining that list. And we have another list of
I am just pitching in to let you know that I think there is some power outage at our institute, and I am at UPS, so I am able to talk to you. Dr. Pilli will soon join and lead us to other modalities. I think we can invite other persons present here for their saying. Dr. Ashwath. I think it's, yeah. So I think we have other people. We can request them to to invite them little in the between the program. Meanwhile, Dr. Jaykumar, may I request you to continue with your talk now, if you are ready, please. Dr. Jaykumar, Vati Shankar.
Yes, sir.
Yeah,
Yes, sir.
please. Welcome,
audible?
please.
Thank
Yeah,
you,
you are
sir.
audible. Please go ahead, please. Welcome.
Is my screen visible, sir? Shall we
It
proceed?
is visible. Yeah, it is visible. Please proceed. Thank you very much.
So,
Please.
thank you. Thank you. So, I welcome all the participants, coordinator who are there. Today, we're going to cover the first topic in QT-03 Basics Quantum Programming. Okay. So, the first subtopic is about basics of programming and data structure. And this is similar to classical programming. So, most of the part relevant to classical programming, side by side, we are able to compare with how classical programming differs from quantum, right? So let me introduce myself. I'm Dr. Jaykumar Vaidya, founder and CEO of Anutandra Private Limited. I'm also IBM quantum educator for past 5 years, and also I'm IBM certified associate developer, quantum computing using Qiskit 0.2x. Okay, and also I'm serving as IBM Qiskit advocate mentor, where I can see I can promote the software and I can represent. So let me introduce about the basics of programming, why we go for programming. The first question we need to ask. So let's say the great saying by the technical top James, the only way to do great work is to love what you do. Okay, so without loving anything, we cannot do the basic stuff. Okay, so this is quoted by Steve Jobs. So all of us know how Apple companies evolved and produced quality of product and retained its standard.
Yeah.
Is the screen is visible, sir?
Screen is actually blank. It is saying you are going to share content, but it is not showing content actually. Now it's showing. Now it started. Yeah, yeah. It's
Fine,
visible
sir.
now. It's visible now. Thank you.
No, sir. It is visible?
It's visible. Please go ahead.
Oops.
Thank you.
Okay. The programs must be written for people to read and only incidentally for machines to execute. Okay. So most of the time we are thinking we are writing programs for the machine. That is not true. Most of the time we are writing programs for people, because if we are able to understand in proper way, if we are able to comprehend in proper way, then only machine able to do in the same way, because we are giving the instructions, right? So first we need to solve the problem, okay, theoretically, then we try to convert into coding part. So no video, see. Oh, there will be little lag, so please wait for that. Otherwise you rejoin. If video is not visible, please rejoin. Yes, audio is also not working, please rejoin, please. So as of today, quantum system do not operate in isolation. Okay, they rely on classical computing system for a variety of essential services. Okay, so it is like a hybrid. Most of the time we need to wait for integration. Okay, so we have intermediate screen, right? So we use classical system. We have program, and we need to write everything in classical system. Then we need to pass through quantum system. So it is like hybrid computation. Wait a second. Wait a second. Wait a second. I shared entire screen. Is my screen visible now with PPT, all the contents?
It's visible now.
Thank you.
All
Thank you.
5 lines are there. Thank you.
Fine, fine, fine. So what we do, we will use classical system, we'll write classical programming, okay? Then we'll use quantum computer, then we
It
do
is off again. It is off again actually. I'm sorry to disturb you.
No issues.
Again gone off actually. Blank screen is coming.
That is why I shared entire screen.
Yeah. I think window may also be good if you want.
Fine, fine. Is my screen visible now? I shared particular screen, PowerPoint, nothing else.
No, we are waiting. It's not still. It is not showing, sir. To Jaykumar. We are not able to see.
Now, sir?
Something might come. It is saying wait. Starting to share. Yeah, it's visible now.
Sorry.
Basics of programming and
Sorry.
classical
Yeah,
quantum.
yeah.
Yeah, please, it's visible. Please
Fine,
go ahead. Thank you.
So what we do, we'll use classical system to write all our programs. And we'll use quantum computer to do all computation. Then finally we'll get hybrid computation. So as usual, if you are using all your inputs like classical user inputs, processing, display results, okay, managing job payloads, everything we need to do all these normal computational tasks, right? So currently the execution of quantum jobs is made possible through specialized library that serves as interface between users and quantum hardware. So what we are doing now, we are using cloud service. We are using cloud-based service to access quantum system, or you can say real quantum computer. Okay, so this is the essence. So for this course, what we're going to cover, we will cover IBM Qiskit. We already covered in QT-02. And if it is possible, I will try to introduce Google Circ and Microsoft Q Sharp. Penny Lane we covered in QT-02, and this is also covered in QT-02. And we try to cover Amazon bracket and NVIDIA Q. Okay, we try to cover all the vendor different types of platform to write a program to execute any quantum system. So what is the use of using all these packages where you can construct circuit and you try to simulate your circuit and we are able to execute. So all this stuff will come under simulation. All this stuff will come under simulation. But if you are using quantum system, a real quantum computer, okay, so this will come under real processing. Okay, so 95% of time what we'll use simulators. Okay, 5% of time what we are using actual system, because actual system are costly, actual quantum systems are costly. That is why for learning purpose to know how it works, we'll use 95% of time using simulators. So there is no restriction to use simulator. You can use 24/7, 365 days. But using actual quantum system is very costly, and you have very limited amount of time to access real system from IBM and Microsoft and Amazon. You need to pay. Okay, only premier user can use real system. So as learners in this quantum computing field, it is imperative to develop proficiency in utilizing these libraries. So you might come under EC background, EEE background, mechatronics, okay, mechanical, but you need to learn the basic programming. So this is prerequisite because we going to deal with quantum systems. Okay, so in this program, what we're going to learn about, we try to understand how to formulate and execute quantum programs tailored to the specific computational problem will allow us to harness the potential of this revolutionary technology. So most of our result lies over quantum program. How good you are writing, how good you are writing your quantum program. You are writing your quantum program. Okay, so in future, code assistance will come. Where if you are giving any inputs, okay, if you are giving any inputs or any scenario, automatically it will generate coding part for you. Okay, we cannot rely 100% over code assistance. Sometimes it will give the correct code, sometimes it may give the wrong code. Okay, so we cannot believe 100%. So that is why each and every one of us, we need to learn basics of programming. Okay, so by mastering all these basics of programming techniques, okay, we'll be able to do scientific discovery. We are able to do optimization of all our problems, and we are able to do quantum cryptography. So whatever the field you are belong to, there will be a certain difficult task which is not able to solvable by classical system, even supercomputer. For those type of problems, you can look forward to quantum systems. Okay, so that is the basic aim of this course. So everybody invited to learn programming. Slowly they can take forward towards quantum programming, right? So there are various programming languages are available. Okay, so according to your domain, this will vary. Okay, so we need to pick our languages according to the problem statement or according to the environment. So take an example of Python. Okay, take an example of Python, C, C++, Julia, Rust. So these are most popular languages used by researchers and scientists across disciplines like physics, mathematics, and engineering. So in future, anybody from any stream, okay, they able to do programming without much software programming knowledge. If they have very basics, they able to write programming, because this code assistance will help them okay, to write program for themselves. So sometimes what a physician thinks, the same way the software engineer not able to think to solve that problem. So this misunderstanding will lead to how to put a different output or not actual what we deserve for that. Okay, so this type of problem we can avoid in future. So for particular example, if you are looking at C and C++, okay, so my favorite is C and C++ because if you are using C and C++, you are able to directly control over your system resources. So this is very pinpoint. Okay, if you're using C, directly can access hardware, you're able to control each and every minute thing. So choosing C and C++ will allow you to do performance optimization in large scale simulation and real time system. So most of the HPC are built over C and C++, right? So most of the HPC built on C and C++. So in future, they're going to integrate C and C++ with quantum systems. Okay. Even though these languages are powerful, they require a deeper understanding of memory management, and it will be more complex to work with. If you're using C, it is straightforward, okay, flat language. But if you're using C++, it is object oriented, which is little bit tough. You are adding a extra abstract layer over C programming, which will do a multiple task in easier way. Okay, but both programming languages will deal with real hardware system. I basically prefer to work with C because it is 20 times faster than Python. So if you are looking for Python, so slowly, gradually, you try to learn C also, because if you want to have high performance system, please go with C libraries. Okay, so I want to highlight, yes, great, wait for a minute. I want to highlight about Julia. It is a relatively new programming languages designed for high performance numerical and scientific computation. So this is equivalent to Python. So if you are looking for syntax and structure, okay, Python is very convenient for all users.
I think
Okay.
we lost your voice for about few seconds.
Now audible, sir. Now audible.
Now it is audible. Yes, now it audible.
Fine.
Please.
Okay. So Julia is equivalent to Python syntax, but it is as equal faster when compared to C. As equal faster compared to C. So if you want to learn versatile language, I prefer go with Julia, because in future, most of the library, they will build in Julia and Rust. So this is what I discussed. Julia combines the speed of C with the level of simplicity that it makes ideal for tasks such as solving complex differential equation. So most of the time, okay, the scientific computation involved with differential equation. Okay, if you're able to solve a differential equation or partial differential equation, you are able to do most of the scientific operations. Okay, so Julia is best suitable language to do all these tasks. Okay, it will help to do a large data set. It is very new language. It will take some time to pick up. Okay, so you might give some time to learn Julia also. And Rust, somebody asked about Rust. Rust is become increasingly popular due to its ability to ensure memory safety and its support for concurrent programming. So if you want to do parallel processing, okay, if you want to do concurrent programming, then Rust is suitable for you. I will share this slide, so don't worry. All the recorded video will be available in YouTube, so don't worry about little jitter delay, right? So if you compare with C and C++ don't have memory management. So user need to handle all these memory management tasks, but Rust will handle in efficient way. So this is the basic difference between Rust and C, C++, right? So all these features make it excellent choice for performance intensive application that require high reliability. So if accuracy is important and reliability is important, you can go for Rust. So in future, Rust is going to dominate all these languages. Okay, because it is equivalently faster, equal to C, as well as easy compared to Python. So despite of all these advantages of these languages, Python become emerged as language of choice for many in the scientific community. So if you are looking at IBM Qiskit, IBM Quantum Qiskit, so this is a software framework. So this is a software framework. Okay, where Qiskit stands for Quantum Information Science Toolkit. So this is the abbreviation of Qiskit, where you can do all types of quantum information processing within the given framework. Okay. So because Python is very simple and it is very readable, make it incredibly accessible for each and everyone. So anybody without any computer programming knowledge, they can easily learn this Python, right? So Python contains very rich ecosystem. So that is why people prefer go for Python. Okay, take an example of NumPy. It is for numerical computation, SciPy for scientific algorithms and computation, and Matplotlib for data visualization. So whatever you do in programming, okay, it is easily able to do all tasks within a single language. So it is very generic. Okay, it is very generic. Okay, so if a language is generic, it can be applicable to n number of domain. Okay, so this is how Python became popular when compared to C, C++, and Java. Okay, because of easiness. So in this whole QT-03, we are about to concentrate about Python. Okay, because it balances ease of use with powerful capabilities. So if you want to do a rapid prototypic building, you can go for Python. If you want to do data analysis, okay, if you want to do simulations, okay, you can learn Python within 2 or 3 months. And you are able to master within 1 year. You are able to master Python within 1 year. So this is how Python become more popular and familiar when compared to all programming languages. So that is why most of the quantum computing library are written in Python because of all these cumulative reason. Okay, most of the library packages, software written in Python. Okay. So let us discuss about fundamental principles of programming. Okay, what are the key principles of programming? Okay, so programming need to be have clarity, and it should be very simple, and it should be modular. Modular in the sense you are able to subdivide. You are able to subdivide. And if already package is there, if already built-in package is there, built-in packages are there, don't try to create. Don't try to create. Use it. Okay, don't try to create. And programming should be efficient one. So anybody can write programming, but how efficient it is based upon the performance. So if you are writing a program, it should be efficient one, and you are able to manage it. If you are writing a program for 2 or 3 pages, it is easy. But if you are writing for 1,000 pages, 1,000 different module, it should be manageable. Okay, so software management is very important. It should be modular. So the manageability and modularity are very dependent. So if your software is modular, then it is easily able to manageable. If any error is occurred, okay, error should be handled in proper way. So if you are writing program, there should be error. It should be logical. It should be, it could be a syntax. Okay, syntax error are very easy. So I try to highlight two types of error. One is syntax. One is semantic. So syntax error is very easy because your software will identify the user able to easily clear this. It won't allow to execute. If there is a syntax error, your system will not allow. But semantic is logical error, which is very, very difficult to identify it, difficult to fix it. Okay. So you should be very careful about semantic error. You should be very careful about semantic error, right? So if you're writing a software, it should be scalable. Okay. You should scale to large number of quantity. Either you can scale it up or you can scale it down. So both should be possible. If you're writing any software or if you're writing any program, it should be have a scalable nature. Okay. If you're writing any code, it should be testable. Then only able to guarantee the quality of your software. Okay. So most of the software relies on abstraction. So how will you put abstraction? So it will hide all complex task. It will reveal only the important things. Take an example. If you are using your laptop, you are using hardware. Okay. But your software do abstraction. You no need to know about your hardware. Okay. What software will do? It will do abstraction. So without knowing your hardware, you're able to use it. So this is what called abstraction. Okay. So all programming, all software is kind of an abstraction, right? So we'll cover all these key principles in upcoming lectures. Okay. So once you know all these principles, it will serve as essential guidelines for creating a well-structured, efficient, and maintainable code. If you're able to achieve this, then you can call it as a good programming practice. So this is the ultimate goal of this course. So each and every one of you able to do a well-structured program. It should be efficient one, and you are able to manage your code if you are scaling up your code into thousands of lines. I'll take a question at last QA session. So mastering this principle is very crucial for any programmer. Okay, it will be giving a foundation for building complex system, writing clean, understandable, and scalable code. So this is what I repeating in each and every slide, right? So what you can do by learning all these fundamental tasks, the developer can create high quality code. So this is what industry is looking for. Okay, if you're using ChatGPT, okay, it will generate code, but it is doubtable. The quality is doubtable. Okay, we cannot believe the code generated by ChatGPT. Okay, so if you are doing any real world task, you are able to have the responsibility about the code. Okay, we cannot believe the ChatGPT code because it is generated by a random algorithm. Okay, so most of the time, okay, where you are involving the scientific computation, the humans are involved. Okay, the developers are involved to create high quality codes. So if your code is a high quality, then it should possess all these parameters. It should be efficient, it should be scalable, it should be reliable, it is able to easily able to maintain. Okay. So let's discuss about the first topic, programs or algorithms for computer. Why we are writing program? Because program will serve as algorithm for computer, because computer only know how to do, and users, we developers, we need to tell what to do. Okay, so this is your hardware, this is your device, and you need to master your device. So here, sorry, the developer should master the device, able to control it. So according to developer requirement, the device need to serve. Okay, so how we are doing all this stuff? By writing coding. By writing coding, you are doing all this stuff. So programs will communicate with the computer and tell it what to do. So program will act like an intermediate. It is acting like a language. It will communicate with your hardware to do the given task. Okay. Then how can you define algorithm? Algorithm can be expressed as programs in many different programming languages. We already covered C, C++, Java, Python. Okay. We can use any language to do your task, and each and every language use different syntax, grammar. Okay, syntax is equal to grammar. And commands, they all share the same set of logical concepts. So irrespective of your language, so what we are doing, we are using algorithm concepts or logical concepts. So we are applying all our logical concepts through programming syntax. So this is what it means. So what is a computer? Computer is a machine for computation. Okay, essentially it is there is no big difference between an abacus and a computer. It is a device. Okay, so abacus is a mechanical and computer is electromechanical or electronics, right? So what is the meaning of computing? It is about operation. It is about operation, or you can say process. So compare with computer, computer is a device. So computer is a device. Okay, computing is an operation. So if you are using your computer to do something, then that process is called automation. So for to do computation, we need to give input data and we need operation. So according to your input data, we need to perform all operation. Okay, so output is your expected answer. So this is what you expect. So this is generic. Okay, if you are from computer science background, please pardon me. Okay, because the audience is from wider source, so we need to cover from basics. So actually this model is proposed by Alan Turing. I will introduce him. So Alan Turing is the scientist who invented a Turing machine concept. Okay, so the computer should have some input. You are feeding your input to your device and it will generate output. So this model is proposed by Alan Turing. This model is proposed by Alan Turing. Okay, so the whole computer is built upon John von Neumann architecture. So the whole computer, the whole modern world computer architecture is based on John Neumann architecture. So what is this architecture? What is this architecture deals about? it will store your data, it will do computation, then it will forward. So in short form, you can say this architecture about store and forward. So in each and every component, it will store data, it will compute, it will move to next component. Okay. Whatever the device you are using, your computer, your laptop, your cell phone, everything is based upon this single architecture. Little difference are there, not much more difference. But quantum is entirely different. So let's think about the major components of computer. So most of us know, so I will skip short. Okay, the CPU, the hardware, memory also hardware, and we are using database which contains series of wires where you can transfer all your data. So all your data are transferred over here. All your instruction, all your control will transfer to instruction bus. Okay, so this is where you can locate your data. By using address bus, you are able to locate your data. Okay, this is the basic architecture of computer. So all of us know. So if you're looking at quantum computer architecture, here we are using, I will use different color. Here we are using classical computer. Take an example of your laptop, or you can use your CPU where you can write even quantum programs. You can write quantum programs. Okay, so all your programs are transferred into control electronics. So all these control electronics will convert into microwave pulses. It will lead to your quantum processor. So here your quantum processor lies. It will do all your computation, okay, using quantum system. It will give back result to your control electronics. Again, all these pulses are converted, measured, okay, it is converted into classical, into binary form. So here you can see it is about binary data. So all this part about binary form. So here all your data in quantum state. Okay. So most of the time, all your binary data, classical data are converted or embedded into your quantum program. It is forwarded to your quantum system. Your quantum system will do all your computation. It will give back result to your classical system. So it could be classical computer, laptop, CPU, or supercomputer. It could be anything. Or it could be HPC. It could be anything. This part could be anything. Yes, if you have any doubt, you can put in chat box. Yes, if it is solvable, you are able to do programmatically. So this is the in detail structured about quantum computer framework. I will share this slide. Please go and check after this course. Let's discuss about why we need programming. Okay, most of us, we know Charles Babbage is called as father of computer. Okay, he laid the foundation for all our computation. Okay, initially we are using mechanical computer. So this is the mechanical computer what we used in ancient times. Okay, and Ada Lovelace is first programmer. She is the first computer programmer. So she will program all these punch holes for this mechanical computer. So in those times, programming is different. Okay, everything is hardware related. Okay, and this is the generic form. So if you have CPU, all this program counter will have a binary form. Okay, binary data. Okay, from your CPU, you need to access your memory. Mostly it will called as RAM, or you can say physical memory. Okay, so all these locations are located by or referred by address bus. So recall the previous slide. Okay, where you need to give instruction where to read. So your data are fetched from your RAM to your CPU. So most probably your data will be stored in register. Okay, so the instruction data are fetched from memory to CPU for processing. If you want to do data process, then you need to fetch data from memory. So it is like to and fro. Okay, so all these results are written back to memory. So if you do computation, your results are stored back to memory. But in quantum, you are not able to store your data. Quantum is not suitable for storing data. Okay, and quantum memory is not available right now. Quantum memory is not available. If you want to store, you can store for a fraction of seconds, for fraction of milliseconds, that too in quantum states. This you need to remember. So this is the basic difference between a classical programming and quantum programming. Quantum is not suitable for storing purpose. Okay, we cannot rely about quantum memory. We only focus on quantum computation. So if you want to do high level programming languages, okay, so it is like what we are talking, whatever I'm talking in English, you are able to understand. In the same way, if you want to write a programming to a computer, we need to use high level programming languages, right? So computer language is a media that we communicate with computer. Okay, this should contains about so many layers. Okay, so this will help like a intermediate persons. The interpreter translator, it will translate high level programming into low level machine code. So this is the user, this is the developer. If you are writing a program, it is in high level. It could be Python, okay, it could be Rust, it could be anything, because it is easy for understanding, easy for writing, because it have natural language form. Okay, so here translator and interpreter will act like intermediate. It will convert into binary form. So that is called machine code. So whatever, if you are looking at 1-0 combination, whatever if you are looking for 1-0 combination, it is in machine code form. So instructions will act like a binary code. Instructions and machines only accept binary codes. So that is why we need high level programming. Okay, so computer only knows zeros and ones, only understands zeros and ones. So all these zeros and ones we are giving like voltage levels. So if you are looking at device level, we are segregating zeros and ones in terms of voltage. So 0 means 0 to 2.5 voltage. Okay, so 1 means 3 to 5 voltage. So we are segregating the voltage level into two level system. So that is why it is called binary system. Okay. So if you're looking in depth, everything is voltage variation. So this is your machine code, combination of zeros and ones. And this is the assembly level code. Okay. For our convenience of operation, binary instructions are denoted with readable symbols. So these are readable. So if you compare this, this is much easier. So these you can say instruction language, or you can say assembly language. Okay, so we are making our language communication in much easier. So in same way, we are using high level languages. Take an example of Python. Or C or C++. It is much more easier able to understand. The same thing we are doing in three different levels. So this high level language converted into assembly. Again, this assembly is converted into machine code. So this is what we discussed. Whatever you are writing program in high level languages, okay, that is converted into machine code with the help of a compiler. So here you can have a compiler, or you can have interpreter, okay, you can have assembler, okay. So many layers are there. This will give the basic idea. Okay, suppose if you're writing a program in a text file, okay, if you're using a text editor, Notepad, WordPad to write a Python code, okay, so all these are instructions. If you're writing a program, it is basically a list of instructions, right? So this program is converted with the help of a translator. It should convert into machine code. So this will happen over here. All your high level code is converted into machine code, and your machine will execute this binary code one by one. Suppose this is the first instruction, it will execute. Next, it will execute the second instruction. So likewise, it will execute one by one. So different translators lead to different programming languages. So each and every programming language have different translators, different compilers. So this is an example of lifetime of a computer program. So if you are writing a program using text editor, you are writing a C program. Okay, what you're doing, you're using some software compiler, and your high level language is converted into machine code. So this is machine code in binary form. This is high level language, right? So if you compile and if you execute, you can store in your hard disk if you want to do for longer duration, okay, and you are using your operating system to visualize your output. So this is lifetime of your computer program. So if you're looking from C perspective, so from 1965 C is started, okay. C is evolved into Object-C, and Object-C evolved into Java evolved to C++, and Java is evolved to C#. In same way, Python is also branch out of C, okay. So if you want to master any language, try to master C. So try to master C programming, so which is very basic, right? So easily you can conquer all other programming languages. So because of simplicity, we are using Python, but personally, I recommend please go with C, then slowly, gradually move towards Python. Okay. So we are about to cover Python. So Python programming language is designed to be easy to read and simply implement for algorithms. Okay. There is a huge number of libraries. That is why we are using Python, because Python have more and more textual. It could able to extract patterns. So that is why Python become more familiar. So initial days, Python is used for data extraction or pattern extraction. So once you know how to use Python, you're able to do graphics, you're able to do data analytics, machine learning, and much more. And Python main weakness is it will be slower when you compare with C. Okay, it is 20 times slower. 20 times slower when compared to C. So this is the major disadvantage of Python, even though it is easier for programming, but it will take lot of time. It will consume lot of time. So let's discuss about the difference between data and information. Okay, most of the program we write will keep track of some kind of information and change it with action. We call those information as data. So data is nothing but raw fact about something. Okay, if you're able to process this data, then you will get some useful information. Because of this purpose, we are using system, we are using computer. Okay, so data have different types depending on their properties. So we'll try to start with three cores: numbers, text, and truth values. So this is the broad introduction to data structure. Your data structure will be looking like simple data structure, and it could be compound data structure, right? And simple data structure, I will use laser pointer. You can create an array. Okay, structure is much more complex when compared to array. I have internet, I think so. And compound data structure will be divided into two: linear and non-linear. And in linear, you will have stack, you have queue, you have linked list. So in non-linear, you could have tree and graph. So according to your data, you need to decide which data structure you need to use. I will pause. Sir, is my screen is visible? Am I audible?
Screen is visible. Python is simple and highly useful. That is what is visible.
Okay.
But I think you are. Can you move the slides backward and forward?
Now, sir, types of
If you
data
can move,
structure.
we will be able to see, because presently the slide that is shown is Python is simple and highly useful.
Okay.
For some people it is not
Then I will
visible.
stop. I will reshare.
Right, sure.
Is it visible now?
It is coming, sir. Not yet.
Types,
Yeah. Not
types
yet.
of data structure.
No,
Now.
not yet. Yeah, like last time only. I think it is loading. I think.
No, it is coming.
Types of data structure.
Yeah, now it has come, sir. Yeah, please go ahead.
Thank you. So if you're looking from statistics, okay, the same data type can be differentiated into categorical, numerical. In categorical, you can again classify into ordinal, nominal, in numerical, interval, and ratio. So data structure, you can have view from different perspective, from statistical, from programming, from language perspective. So data types will differ. Okay. So if you're looking from programming, data types in programming, majorly it will lead to these 8 types. One is integer, floatable, character, string, boolean, datetime, arrays, 2D array, and multidimensional array. Okay, so difference between integer and float, it is much more complex. It is much more complex. Okay, it is a single character and it is combination of characters. Okay, so boolean will have only 2 values, 2 types, like binary. So you can say either 0 or 1, 0 or 1, true or false. Okay, so all this stuff, it will come under boolean. Okay, so you need to understand your data to select your data type. So this is very important in programming. So what are the skills that you need to acquire? You need to look at your data and need to identify what suitable data type you can declare. Okay, so data types in Python, we are about to cover language specific. So initially we covered about programming perspective, programming. Second, we look about statistical point. Next, we're going to cover about language perspective, especially Python. Okay, so each and every language offer limited type of data type. So this is again limitation. Okay, so whatever C offers, whatever C++ offers, you cannot have all data types in Python because each and every language is unique. The data type offered also unique. Okay, you need to understand this basic difference. So Python data type, again, you can see like numbers. Numbers will branch into integers and floating point. Here you have fractional part. And also you can use complex numbers, real part and imaginary part. Okay, so you need to know why you need to pick the data type to represent your data. Okay, here your data is more important. You need to identify. You need to identify its nature. Then you need to pick your data type. So this is what I suggest, right? So we'll cover all these data type in subsequent lectures. Let's see the basic and very simple integers. So integers starting from 0 to infinite values. Okay, whole numbers. Okay, so floating point you can represent with fractional part. So here the size is somewhat small. Here the size is somewhat large. So if you're choosing floating point, you need to allocate more memory space. Okay, and if you're computing integers, if you're doing computation, it will take less time. Integers will take less time. Floating point will take more time. So picking data type will lead to computational efficiency. So multiple factors are involved. Okay, it is not simply about choosing data type. It will involve subsequent operations, storage space, everything included your data type. So you should be very careful about your data type. Okay, and floating point operation are much more complex in computer science because most of the time we need to do approximation. Okay, most of the time we need to do round off. So this will give a computational complexity or computational overhead. So this will do computational, it will add computational complexity, and it will add computational overhead. Okay, so good programmer always think twice or thrice about their data type. Okay, take an example of addition, subtraction, multiplication, division. Okay, whatever we are using conventionally, we will have a different version in Python, right? Overhead means extra computation. Or you can say simply additional, unnecessary. Oh, burden, right? And we are using parentheses to specify the order to evaluate operation. So if you are learning C, C++, Java, it is much more complex. But if you are using Python, it is much more simple. Okay, so take an example of 4 double star 2 or 5 minus 2 bar 3, where this will take first order. It will do 5 minus 2 first, so you'll get 3. So 3 divided by 3 equal to 1. So this is how it will evaluate. So that is what given over here, right? So this is an expression. Okay, if you have multiple piece of expression, if you have combination of expression, okay, it will evaluate the given data value. So if you are writing program, most of the time you are using arithmetic operation and logical operation, and you are doing in combination. So this is all about your computer. So whatever your computer do, you can classify within these two major operations. So most program we write will keep track of some kind of information. Okay, and that is called data. And each data have different types of depending on their property. Okay, so take an example of floor division, or simply div. Okay, so it is not like 7 by 4. So it is floor division, which is not equivalent to 1. Okay, it is not equivalent to 1.75, it is equal to 1. So it will round off. So this division will round off your answer. So this is like trade-off. So what is the operation you need to do? You need to think before choosing your operation. So in the same way, if you're using modulo, so frequently you are using modulo in cryptography, it will find remainder when one number is divided by another. So mostly in our school days, okay, we won't use modulo. Most of the time we will use division. But in computer, these two are very special and more frequently we'll use. Okay, so 7 modulo 4 is equal to 3. So we need to know this basic difference. Okay, so this Day-1 mod used for floor operation and repeat value. If you want to do a repeated task, okay, whether a number is divisible by another number, we need to do repeated operation. For those, you can use modulo. Okay, for extraction, for digit extraction, or to check divisibility, you can use modulo. Right. So if you want to implement text if you want to store text value in Python, okay, you can call it as string. Okay, so in two way you can represent either by single quote or either by double quotes. So if you are giving any text within single quote, okay, it is stored as text or double quote. Okay, so strings can be concatenated together using addition. So addition is mathematical operation, but you can use in textual context. So this will lead to concatenation. So this will bring two texts together. Okay, take an example. Hello is first string. Okay, world is second string. If you're using plus a arithmetic operation, but it will sense the scenario. So both are text. It will do concatenation. It will combine both text and it will reproduce a new word. Okay, fine. Suppose if you try to mix different data types, what happens? It will cause error message. Take an example of error message. It is how the computer tells you it doesn't understand a command you read, because you need to follow the grammar. So if you are speaking a language, you need to follow grammar to have meaningful conversation. In the same way, you can write a program in order to avoid any error message. Okay, so take an example. So here it is a string. It is a number. If you try to mix, it will give a type error. Similarly, if you are using hello minus world, so here it is arithmetic operator like minus. So there is no meaning in Python. No meaningful operation in Python. So that is why both will give error. Yes, hello plus world, it will work because it will bridge two words. Python have meaning. They already defined. So already defined, okay, it will work. The both data types are same. And you can merge two words. With the help of plus operator. So already they define, that is why it is working. So if you're learning languages, you need to know all this stuff. So this is very important operator. We can use Boolean, okay, where if you want to represent only two values. So plus or minus, okay, black or white, yes or no, okay, man, woman. So if you want to denote two different things, only two different answers, you can go for Boolean. So it will save your memory space, okay, if you declared in Boolean, because it will take only 1 bit storage. Suppose if you want to store yes, okay, you need to have large number of bits. You need to convert into binary. Okay. If you want to store no, again you need to have large number of bits. But if you're converting yes or no, if you are attaching to Boolean variable, okay, automatically it will assign 0 or 1 for these values. So this will take only 1 bit. So this is the logic. If your answer have only 2 states, you can go for Boolean. So you can reduce your memory space, reduce your storage space. So this is how you need to think if you are writing a program, if you are learning a language, what are the best possibility to pick your data type. Okay, you need to understand your data, then you need to decide which one is suitable, which one is more efficient to represent for the given problem or given statement. So same way you can use comparison operator, lesser than, greater than, or lesser than equal to, greater than equal to, okay, not equal to. You can do all these comparison. Suppose if you want to do some mathematical function, okay, which is already have built-in function, built-in operators. So this is why Python become more famous when compared to C, C++. It have a variety of built-in function and packages where you can easily run any given problem statement. Suppose if you want to know what is the data type of a given function, you can use type value. So type value is a built-in function that determines the type of given value. So you can re-engineer, okay, or identify what is the value stored, okay, what is the data type it belongs to. So it is very easy for us to know what is the data type from the value, right? If you want to convert from one data type to another data type, it is called typecasting. Okay, sometimes you need to convert or change. Then you can go for typecasting. For an example, if you evaluate string 42, it will evaluate double quote 42. If you want to evaluate in 3.14, it will convert it into 3. Are you able to understand? Right? So you are giving an integer value, but you are using a string function, it will convert into string. Okay. Here you are giving a floating point or fraction, and you are using int function. It will omit the fractional part, it will store the whole number. So here trade-off will happen or round off will happen. So if you're converting, you should be very careful, okay, from which data type to which data type it is converting. So you will lose some information if you are using typecasting. So you should be cautious while converting one data type into another data type. So this is an example. You go to any online editor, try some Python code. Okay, you are able to run all these sample codes. And if you want to store a larger number of lines, go for file. So if file length is long, you store as in a Python file. Store as a Python file with extension .py. So I'll stop it here. I'll stop it here. So if you have any generic question, you can ask. So within 1 hour, we are able to give a basic outline about Python and data structure. I'll share reference. I will share some basic program. You can try and run. Python is very easy. Even school students, they can learn on their own. Definitely, I'll share
PowerPoints
PPT.
will be PowerPoints will be shared. The video recording will be shared. The link will be shared. Some of you may be struggling to get into Canvas, so please make efforts. The process is Canvas login is important because that is where the exams will be conducted, and it is important, right? So, of course, Radha Krishna will help you, Dr. Vikash will help you, and others. So, Dr. Anand Mishra is there, so we'll all help you. Dr. Jaykumar's slides will be shared. So after that, we'll also share the video recording, and the attendance also will be shared. So thank you. Dr. Jaykumar, any more instructions from your side?
Yes, sir. I try to answer few very good questions. Question from Rao,
Yes.
VCV. Python performance is not good. Why do they consider for QC? Because for QC, multiple people need to join. They are from different backgrounds, from ECE, EEE, mechanical, mechatronics, even from physics, chemistry. If they want to learn some basic programming, Python is very suitable. So it is user friendly, beginner friendly. So that is why they choose Python. Okay. So whatever happens in future, definitely it will move towards C and Rust. So this is the latest update I got before a few days. So most of the company, they will move their code base to C and Rust.
Rust.
Yes, sir, Rust.
So most of these flavors will be shared by Jaykumar sir. We'll also have a flavor of QSIM and Penny also. So we'll go by the syllabus as of now. Please bear with us. Some of you may be very good in Python. So, but still you'll have to go through this because this is part of QT-03 syllabus. Most of the contents we have tried to, try to shrink it, and we will deliver the other things. So that's the idea that you can look at, right? Some of Jaykumar's team will present Java for quantum computing. Some of you may be very, very good in Java. So that's one thing. Yeah. Sir, you would like to answer? All classes going to be theory or practical applications?
It is mixed, sir. Wherever possible, we try to run the code.
Yeah, so all of you, please be available on the laptops or desktops, wherever you prefer. Because on the mobile, it may not be very easy. So the beautiful thing is that we have to do that. You can do online, and in fact, videos, if you see, Dr. Jaykumar, we have time for you to run the things. He'll give you the sample code also. You'll have to run it. So you can set up some of the things of setting up also. We'll share slowly. So during the class, it's a like a hands-on. So while he is teaching, he will expect you all to do the same, and you can clarify the doubt. So that's a process. So you can do that. Yeah, some introduction will give. Yeah, regarding the PG diploma, we will announce. We'll make a formal announcement and send you the document what is required. We'll see how best we can do it. Right. So we're trying to make it. That's why I'm not able to announce. Once I announce it, I cannot take all those things back. So just give me some time. Right. Thank you. Thank you so much. So we will meet tomorrow sharp at 2 o'clock. Sunday will be off. We'll continue back classes on Monday onwards. Monday to Saturday, we'll have continuous classes. And please note the date change also. There's one change, one mistake in the schedule. May 22nd is coming twice. That is May 29th is where the assignment will be. And I will also add the IBM expert's name. Dr. Ritajit will be taking few lectures, so we'll try to adjust and send you the final thing I'll share in the group, right? Thank you so much. Please remember regarding the WhatsApp groups, respective academies will mail you the group. So for MNIT, Dr. Vikas has sent the email today also. And if somebody has joined just now, we will send again that request for you to join the WhatsApp group, to join the WebEx link, and also to join the Canvas, right? So please try to complete this by tomorrow, and hopefully by Sunday, all of us should be on Canvas and WebEx, and also on on WhatsApp group, right? Thank you so much. About 1,000 participants among all the academies have registered. So last time also there were 1,000 plus, and about 860, 870 people have completed the certification. So hopefully this time also, and this time I think more should complete. Hopefully we'll talk now, right? Thank you so much. Take a break.
Yes, sir.
Meet
Thank you,
tomorrow
sir.
at 2
Thank you
o'clock.
so much.
Thank you. Thank you.
Thank you.
Thank you.